So first of all, this is not a function. This is an ellipse, and how do we know? You don't have to do this. I'm just refreshing your memory. We have to divide by 36. So this is x squared over 36 plus 4y squared over 36 equals 1. I will simplify, of course. And then I have x squared over 36 plus y squared over 9 equals 1. When we graph the ellipse, this is the a squared, and this is the so-called b squared. Why? Because the equation of an ellipse is like this. X squared over a squared plus y squared over b squared equals 1. Since the square root of 36 is 6, and the square root of 9 is 3, because a is 6 and b is 3, the ellipse looks like this. 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is negative 6 and 6, and 3, 3. 1, 2, 3. 1, 2, 3. So the ellipse has to go through these 4 points. Now the point 12, 3, 6, 7, 8, 9, 10, 1, 2. The point 10, 3 is here. 12, 3 is here. This is 12, 3. So good. So now the question is asking us, I think, if I'm correct, find the equation of the tangents to the ellipse that pass through this point. Am I correct? Is that correct? Is my interpretation correct?
Yes.
Okay, perfect.
The two equations.
Yes.
Smaller and larger. Yeah.
Okay. So see, this is one thing is very clear. How do I know? Because y is 3. Okay. If y were like 4, then the point would have been here, and the tangent would have been something else. But obviously, this is one tangent, for sure. But let's ignore that for a second. And here's the other one. So obviously, let's ignore the fact that this is a horizontal line. Let's see, because it's a special case, right? It could have not happened, but it did. So I'm not really interested to find those points till later. So this is a tangent that passes through this point, and this is a tangent that passes through this point. So I'm going to call this line 1, and I'm going to call this line 2, or tangent 1 and tangent 2. So in order to determine the equation of this line, which I already know, it's y equals 3. There is no discussion there for this one, obviously. But in order to determine this equation, I need to determine the slope of this line. Let's forget about this one because it's a special case. It will come out. We'll get back to that. So in order to determine this equation of this line, I know that it's y minus y1 equals the slope times x minus x1. I know that this is a point. I'm going to call this point a comma b. I don't have it. So can I determine the equation of this line? Can I determine the slope? No, not with these 2 points because I don't have this one. But there is another way of determining it. Once I'm done, x1, y1 can be these. They don't have to be these. It doesn't matter, right? Because the line has to pass through 12, 3. So this is 12, 3. But what I need to determine is the slope. Good. How do I determine the slope? Well, I know that this point A comma B, first of all, verifies the equation. It has to, because it's on the equation of the ellipse. So my first equation, it will be a squared plus 4y squared equals 36. 4b squared equals 36. Okay. Secondly, I will determine the slope. In other words, I will find dy over dx, the equation of the derivative, in other words, or the derivative of this. So this is the first thing that I needed to do. Secondly, x squared plus 4y squared equals 36. I apply this operator to both sides. I differentiate, I get 2x plus 8y dy over dx equals 0. I solve the equation for this equation for dy over dx moving to x. This term is okay, but this one does not belong here. So I have 8y dy over dx equals negative 2x. Then I'll solve for dy over dx. So let's stop for a moment. Any questions so far? Any questions so far? I didn't do anything, really. So what I did, I graphed the ellipse. You can say, can I do all this without graphing it? Yes, you can. But first of all, it's easier for me to explain. And I could also check my work. If this equation is not going to be y equals 3, then I know I'm in trouble, because that's what it is. This height is exactly at 3, and the ellipse has the minor x's that starts at negative 3 and ends at 3. So I know that this is horizontal, but I'll disregard it for a moment. Then what I did, I said this point is a common point of the tangent, but also on the ellipse. So the equation, the coordinates of a comma b, in other words, of this point, have to verify the equation of the ellipse. So when x is a squared, when y is b squared, this must equal 36. Then I said, I'm talking about the tangent. So then I have to look at the derivative, which is dy over dx. So I wrote the equation one more time. I differentiated both sides. 2x 4y times the inner function prime equals 36 prime, which is 0. Finally, I have this. I move 2x to the other side, and now I'm dividing by 8y. So dy over dx equals negative 2x over 8y. Yes, I will simplify a little bit. So dy over dx, this is an equation. You notice I cannot simplify and continue. Why do I put the semicolon here? I cannot continue this way. This is an equation. This is the left-hand side, one equal symbol, one right-hand side. So do not continue and write equals to the sides. That will be incorrect. Okay, I'll simplify by 2. So I get negative x over 4y. So this is the derivative. Okay. So now, dy over dx, when x is a and y is b, at that point, this will be negative a divided by 4b. And this has to equal at the same time. So negative a divided by 4b must also equal the slope of this line. How do I know? So this is the dy over dx gives the slope of the tangent line to the graph of the ellipse anywhere. It gives it here, it gives it here, and so on and so forth. But I'm interested in this point that is also on the tangent. So in order to determine the slope of this tangent in another way is having 2 points, y2 minus y1 over x2 minus x1. So this must also equal 3 minus b over 12 minus a, y2 minus y1 over x2 minus x1, over 12 minus a. Now I will attach to this equation, which is a squared plus 4b squared equals 36. Now the question is why? Why am I doing this? Why do I attach this equation? Here's the answer. I have two variables. I have the variable a, I have variable b. Because I have two variables, this implies two equations. If you only give me one variable, you give me two variables and one equation, I'll say, okay, that's beautiful, but how can I determine anything here? I can't, because I have two variables and one equation. But I was able to come up with two equations. One equation was coming from the fact that this point is on the ellipse. The second equation was coming from finding the derivative, plugging in this point in the derivative, x equals a, y equals b. I follow that. But also, these 2 points create this equation, and I can determine the slope of this line in a different way. y2 minus y1 over x2 minus x1. Now, what is my next fight? Solve this. This system. Once I solve this system, I will get this point for sure, and I will get this point, whatever it is, for sure. Once I have these 2 points, I can determine the two equations. So from here, I have to find little a and little b. How do I do that? Well, for this equation, there is nothing I can do for now. But this one, any suggestions on what to do here, what to manipulate, how to proceed? Here it's carved in stone, at least for now. But how do I address this? Can anyone refresh our memory on what this is? What is it? Because if I know what it is, I'll know how to handle it. Say that again.
We cross multiply.
Excellent, brilliant. Who was that?
Victoria.
Thank you. It's a proportion. We must cross multiply. Only in a proportion we cross multiply. What is a proportion? A over B equals C over D. Nothing else follows. If something else follows left and right, it's not a proportion. Don't copy this. It's not a proportion. Now it is. Only in a proportion, which is a special type of a rational equation. Proportion. Special type of rational equation. Special type. Only in a proportion I can do this. AD must equal BC. And this is the only thing I can do over there. Oh, you can say, well, why don't you multiply first both sides by 4b, and then you multiply both sides by 12 minus a. Fine. I'm not saying that's incorrect. I'm just saying it's a proportion. Let's cross multiply. Careful now. This negative has to go to either a or 4b, not both. I like the symbols to go with the top. You can say, nope, I want the symbol to, it's going to be the same thing. So here's how I will multiply it myself. The negative a times 12 minus a, and the 4b with the rest. I will write it out to see it. in front of me. Let me know. Let's stop for a second and see if you have questions. I don't want to move on if you have any questions here. Anyone? Anyone? Okay, so then I'm going to write negative a parentheses 12 minus a must equal 4b parentheses 3 minus b. Okay, so I distribute negative 12a plus a squared, 12b minus 4b squared. I will move everything to one side, maybe. We'll see. It's a mess. I have no idea what to do with this just yet. So a squared plus 4b squared minus 12a minus 12b equals 0. After all this work, I got another equation. So I'm checking my expressions here, just making sure. I have no idea what to expect. So I have indeed negative 12 plus a squared, that's correct. That's 12b, yes, minus 4b squared, that's correct. So I had this first, this second, this here, and this here. Good. So now I'm attaching again. There was no end to this problem. So I'm attaching x squared plus 4b squared equals 36. Okay. Look at that. So a squared plus 4b squared equals 36. So I'm going to replace this by 36 and see what happens. 36 minus 12a minus 12b equals 0. And then 36 equals 12a plus b, or a plus b equals 3. So what I did, again, I realized that a squared plus 4b squared was 36. So I replaced it in the first equation, and then I moved the 12a minus 12b to the other side, factoring they were negative. When they move to the other side, they become positive. So I factor out 12. I divided both sides by 12, and I got this. Okay. Okay, so from here, I could say that a equals 3 minus b. So now I have to go back and see if I can go back and here and replace a by 3 minus b and solve for b. So a squared, I have to square 3 minus b, which is 9 minus 6b plus b squared. I'm adding 4b squared. I'm subtracting 36, and I get 0. Now, I have 5b squared minus 6b, and minus, what is this, 27, equals 0. I'm going to say stop here for a moment, because we're going to have two b's in a moment. I'm going to share my screen. I want